Okay, should we get started or wait maybe a minute or two?
Maybe a minute or two. Probably it's time to start asking people to volunteer to take notes.
Yeah, we definitely need that.
So would anybody like to volunteer to take minutes? No need to get into excess detail, just action items. Either in the Metaco or the headstock linked here, or any other means you want in emailing to us as you like, but we will need this. So volunteers are encouraged, entreated perhaps.
Or maybe we'll have to draft somebody.
Yes.
So behave or you will become the note taker. Stefan, are you interested in taking notes?
So usually I even volunteer to do so, but today, starting in half an hour, I have to juggle 2 calls.
Oh, okay.
Today, I apologize. No.
Do we have a volunteer for note taker?
Okay, I will give it a try.
Well, thank you very much. Thank you very, very much. Okay, well, why don't we get underway? So in case you just stumbled into this room by accident, we are the AVTCORE working group and we're having a virtual interim for 2 hours. We've got lots of stuff on the agenda. Just a few tips. You enter the queue with a hand icon. I think that's still true. And you need to enable audio or we won't hear you. And you do that by unmuting and you disable by muting. You can also do video separate from audio. It's encouraged but not required. A little bit about the meeting. The agenda is up there on the data tracker. The notes are accessible from Meet Echo in the note-taking tool, which I think you can probably find. I guess we're using Zulip and not Jabber.
I think they're bridged actually, so it's the same.
Oh, they're bridged, right.
Yeah. And it's the chat here, so. Yeah.
And we don't need, as a result, we don't need a Jabber scribe, right? But we do have a note taker.
Yeah, but I mean, I guess the only thing is if somebody isn't able to use their mic for whatever reason, if, due to our family or whatever, you can comment in the chat, and it'd be good if we had somebody who was actively watching that, but we as the chair as well to try to watch it to see if somebody wants to say something that they can't say at the mic. But please use the mic if you're able.
So a little bit about the note well. It's a reminder of IETF policies in effect on things like patents or code of conduct. It's just to point you in the right direction. By participating, you agree to follow these processes. And there are disclosure obligations, and definitive information is in the documents that are described in the link here. Also, we have a professional conduct policy as defined in the IETF guidelines for conduct, anti-harassment, and procedures in the ombuds stream, etc. They're striving to maintain an environment where people are treated with dignity, decency, and respect. And please don't do anything outside of that. And if you believe you have been harassed, you can talk with the ombuds persons. So I guess we do have IETF 114 plans. It's a hybrid meeting. I don't know if it would be useful, Jonathan, to get an idea of how many people are attending in person. We did have decent attendance at IETF 113, as I recall. So how do you want to do a hand raising?
I mean, I don't know if people want to do a hand raising or just comment in the chat.
Sure. Okay, comment in the chat's fine. If you're planning, I guess if you're planning on coming in person, comment in the chat. It'll just give us an idea, I guess, how big a physical room we would need and things like that. for IETF-114. So we'll just take a minute and then we'll move on. Okay. All right. So here is the agenda for today. We're going to start out with administrative stuff, then cryptex frameworking, skip, RFC 7983 BIS, some quick presentations on Web Transport Liaison. I guess Will, you'll handle Liaison because Yanimar has COVID. And then SDP for quick, and then a W3c, and then we'll wrap up and figure out what to do next. So lots of items on the agenda. Okay, so here's the status, I think, where we're at. So the two most recent items we published, VP9 is in the RFC editor queue. I guess cryptex has finished IETF less call on the 5th, and Sergio will talk about the items to wrap it up. VVC just completed IETF less call today, and we will be, I guess, talking about that on the list. Stefan, it's not all the reviews have come in, I guess. I think that's still true. And then Mo will talk a little bit about frame marking, where to go next. We have completed working group last call on skip, and we'll have some slides about that. And then we have two drafts, EBC and 7983 BIS, which are adopted. One thing which has come up with cryptex, I think you've probably seen this on the list, is an IPR declaration has been submitted from Qualcomm, and I sent a notice to the list on the 7th. And so we're required or suggested to ask on the list whether there's any concerns relating to that IPR declaration, or let's just say, are there any objections to proceeding with publication? We have not heard any objections on the list so far. I guess there's no one in the queue, right? Jonathan wants to speak up.
No, I don't see anybody.
Okay, so we'll assume there are no objections. All right, so we'd like to turn this over to Sergio to talk about cryptex.
Hello. So I will quickly go through the status of cryptex. So the slides, please.
Sergio, I am not hearing you.
You don't know hear me now?
Now I hear you. I hear you.
Yeah. So we have reviewed received the reviews from the SecDir, Jenart, and Art. And we have Bernard created one issue in the GitHub repository to track each of the reviews. The first one from the SecDir was just really easy, and I just adopted what they suggested to change. So the issue is closed. And there are two pending reviews for Jenart and Art that I have some. Well, let's go to the next slide. So either their feedback and the items that have been taken and the remaining things that need to be approved. So the first one is an editorial about the SDP declaration that we currently say that the SDP, the attribute takes no value, and they complain that why no value. So I try to find the definition that it was in the SDP when we define the SDP attributes, and it seems that it is an attribute that takes no value is a property attribute. So I have two proposals to change this to clarify that it's further. So I'm not sure if which one of both is more appropriate. So if I mean, we can do a quick. If anyone has a quick feedback now, we can take the action about which one would be best, and if not, we can just, if you could comment it on the issue, it will be great. So the first one is just changing calling it a property attribute. So meaning that and just referencing the RFC for what that means. And the second one is adding a bit more text that as it is a property attribute, it takes no value. So I'm not sure if anyone has any opinion on what would be the best way to go forward.
They sound pretty similar to me.
Yeah. I mean, it's just last where we are in a very just. I think that probably the second one is good enough, but is. Anyway, I will the issues, and this is the issue. So if anyone has to provide any further comment, you can do it in the issue, and if not, I will just merge one PR with one of both of them. So the next feedback is that is when we talk about the encrypted region, and it was not clear what would mean the region for them. So I just replaced the region to encrypt by the term that it is used in Rtp, that it is the encrypted portion. So we use the same name that it is defined in the Rtp RFC. So there should be no ambiguity now, and there is a pull request. There's just to waiting to see if anyone has any comment on that. But if not, I will just merge it. So next slide. And this is a change in the wording that when we explained what should an implementation do if in case that Gristed was not negotiated, but it was considered as mandatory for the implementation. So we said that we should reward this. So I have proposed this alternative wording just to make it more clear what that it is a recommendation to implement. So this is again in the pull request. So if anyone has any feedback about if it is okay or not, I will proceed with it in the following days.
Yeah, just one comment, Sergio.
Mm-hmm.
This is in receiving, right? So it's saying if the receiver is requiring cryptex, not the sender.
Yeah.
For both, I would say.
Yeah,
Well, I mean,
because
it's
on the sender side, at least in the API, right? If it's required, if cryptex is required and it's not negotiated, then it's not. It's gonna negotiation is gonna fail.
I don't recall. Well, I will check what you mean, and I would say
Yeah, like in
if
the
it is
API, there's
yeah.
two settings, right? Require and negotiate. Negotiate allows it to go forward if it doesn't negotiate it. Require requires cryptex or
Yeah, but that
doesn't
would be
send.
in the W3c API.
Right.
So I mean, I think that this is to explain what happens if you put negotiate or required and it cannot be negotiated.
Yeah, it's just similar. Like if you consider it specification mandatory, it just could be a little bit more clear. Like if it's mandatory to use, then it's mandatory to use, and it can't. It's not going to send, right? If you see what I'm saying.
Yeah.
Anyway,
Okay,
I think the terms are a little bit confusing.
I will review it and see if it is affected the sender and the receiver or both, and I will clarify it a bit further. So next item is the next slide, please. And there was a feedback about a typo in one of the diagrams that has been already fixed. And then a comment that if we should define the acronyms for SRTP, SSRC, and CSRC, and the other ones, I don't think that it is needed at this stage if you are looking at this RFC. And the last one is a typo that has also been fixed. So this is all so next slide, please. So this is a recap of the next slide. So I will, if I don't not hear any feedback from the issues, I will just merge the pending PRs, and I will review the item that we have just discussed about the latest clarification about the mandatory to implement or to use in the sender and the receiver. And when it is and I will then create a new draft and publish it so we can continue the process.
Okay.
Mhm.
Thank you, Sergio.
Okay, thank you too.
Bo.
Okay, can you hear me okay?
Yeah.
All right. This is the current status of the frame marking draft. It's gone through last call and received mostly editorial and meta feedback from the area reviews. I didn't include the text of all of the reviews or the text from the draft that was being referenced because they were mostly editorial and meta level comments. There was just only one that's slightly substantive that I have a quote in here from Martin that we can look at. But basically, the general area wanted to clarify the scope of the experiment, its timeline, goals, and INA changes. I looked at other experimental drafts. None of that is in any of the other drafts, so I'm not sure why it's being requested here. We can add a blurb of very general, vague language. I don't know if it really does any good. The larger issue here, though, it's more of a meta question, but the larger issue here is that I don't honestly consider this an experiment. I don't consider people are experimenting with to see how things work out and then change something, promote it to proposed standard. If not, people are either going to use it or not use it. Maybe morph it, but that would be a totally new draft, a different version of the header extension with new semantics. So I guess the question for the work group is, do you really all still consider it an experiment? And if you do you have any input on what the scope, goal, and time of the experiment should be? If not, I'll add some very generic language.
Yeah, I think I agree. I don't really consider it an experiment either. I think there's a tendency to use experimental to mean, I don't think it's good enough for proposed standard, but we still want to publish it. But I think maybe we should say it's informational instead, if that's what we mean. Possibly we should talk to our area director about this. Unfortunately, it's not here. Actually, who's our area director now? I forget.
Yeah, the major distinction of an experiment is it could become a proposed standard in the future, whereas informational wouldn't be promotable. But this idea that there has to be a scope and time doesn't make any sense. I've done multiple experimental RFCs that didn't have a scope, a time, and a goal.
I mean, yeah, I guess if we want to just say, well, let's ignore this and see what the my IHG says, I'm fine with that.
Yeah, I mean, one thing about experiments is you're kind of admitting that things may change. I counted at least 4 of these kind of RTP header extensions, forwarding extensions, right? So it's not like the whole thing is settled and we understand that. That's could be one interpretation of experiment.
Yeah.
Like I said, I can add very generic language. Maybe mention that experimental implementation and deployment experience with this and other header extensions like the AV1 dependency descriptor, and see the pros and cons of each. I can put some very generic language around that in the draft if people think that's useful. People are using some sort of frame markings, whether it's this or their own, or newer ones that are under development. So I don't think it's going to be a concluded experiment in that sense. People are going to keep evolving, how they're marking video payloads. But I can put
and they're obviously they're not all tied to this document because there are multiple documents. But
Stefan?
yeah, I mean, it's hard to give it structure. Like, I don't want, we don't have a charter item in the working group to write up a review of all of these kind of documents, right? And what we learned from them. Wouldn't be bad to do that, but
I see Stefan in the queue.
So I have seen, a little bit of tightening around this experimental status over the last few years. I think you guys have seen that probably too. I'm not surprised that this comment comes up. I would not recommend to go into informational with something like this. You have to rewrite a good part of the document. So I think more suggestion about putting some blah around to keep the procedure gurus happy, and or even if they are not happy, but to address their concern in quotation marks, and then ship it and be done with it is, I think, the path of the least resistance. Thank you.
Okay, so how about I propose the text on the list, propose the change on the list, and then see if that's agreeable to everyone, and that'll go into the next version for.
Or negotiate with these guys. Just negotiate with them. then go to the list. No,
well, the GenArt isn't the same people as the IESG, and it's the IESG who you ultimately have to make happy. So.
Okay, so I think I'll propose some text and send it to the list to close that one out. Obster was probably purely editorial. I'll add some STP reference there. Security Directorate, same. I'll add a reference to RFC 8285's comments about header integrity protection inside of the security considerations. Martin had some comments in the ART review about the wording in one section being better than the wording in the subsequent sections. So I'll go ahead and just make the wording for TID and LID more uniform to match the first section 331. It's just a little bit more verbose, but it's a short document anyway, so I won't extend the length much. The only one thing that's semi-substantive is that he thought that the statement about the header extension values must match the Rtp payload. He thought that was unenforceable. I don't have a strong opinion of whether or not that sentence should remain, but I mean, obviously you don't want, someone shouldn't be misrepresenting what's in the payload by adding, bogus data in the header extension. Maybe that doesn't need to be said. But this was just trying to get at, if a sender knows its payload, it should, mark in the header extension properly to match the payload. Or if anyone has a view on whether that's just an unnecessary thing to say.
It's obviously it's a reasonable thing to do, right?
I think so. Yeah. I mean, the only thing I could think is that, I could imagine cases where it's actually more complicated than that. This is a simplification, but it kind of matches. It's still a reasonable thing to do, if what you're doing is more complicated than framework can represent, which is, honestly often the case. But which I think it's, I don't think, maybe it's unenforceable. I don't know what unenforceable means, since we don't have enforcement for any of this, right? But basically, if you don't do this, it'll break. So that's the whole point of a must. Yeah, if you don't, the whole point of a must is do this or things won't work right, right? And that's exactly do this or things won't work right. So.
Yeah, there's also the question of who is it enforcing, right? Because there's the SFU, which may not even look in the payload, right? So it's just doing everything based on the header extension values. And then there's the receiver, and are we saying the receiver should check that they're the same? I don't know. The receiver may not necessarily even look at the header extension, right? It may just look at the payload.
Yeah, like I said, I think this is a do it or it won't work right, not a somebody has to enforce it for security reasons or anything like that. So I think it's, I need to look at the context to make sure maybe if it's confusing in context, but I think it's, as a requirement on its own, I think it's a reasonable one.
Yeah, so the only thing that I would say that maybe would appease everyone is that we can clarify that the sender should write the header extension to reflect what's in the payload,
right?
Unless it doesn't have enough information
Sometimes you wouldn't. So why wouldn't you? And then you're going to ask, well, when wouldn't you?
So
That's what I was saying. The should, and then unless you're unable to, unless you don't know the
Yeah,
contents of the
okay,
payload well enough to mark it.
that's reasonable. Should unless you don't know seems reasonable.
So that would make it enforceable and clarify that it's the sender that's doing this, not receiver enforcement or SFU
Right.
checks. Okay, so that seems like a reasonable way forward on that one. And then others were just editorial and nits. So on security, we'll mention the privacy and traffic analysis implications of having this in the clear, and some nits on formatting, and maybe people have an opinion about whether or not the title of the document should reflect that it's a video frame marking header extension. Starts to get long, but if people think that's a useful clarification, I'm okay with adding video to the title. It's not really applicable for any other media as currently written.
Well,
Sure.
once you hit keyframe, you should kind of realize it's video, but whatever.
So if no objections, I'll just add video to the frame marking title, video frame marking to the title. And that's it. Next slide. So there'll be, I think I have just one more slide on next steps. So I'll propose the responses on the list to make sure everyone is in line with it, since this meeting is not, doesn't have that many attendees. And then assuming no review, feedback, I'll update the draft and we'll resubmit version 14.
Sounds good.
Sounds good.
Hi, this is Mike Fowler. We're presenting on the RTP payload format for the skip codec. We have been here before over this. My colleague and I, Dan Hansen, will go over some of the concepts and the comments that have come up from the AVT-Core working group last call. Next slide, please. The intro discusses the organization we represent. We've been around a while. The indented second bullet is probably the most important concept to understand. That SCIP is an application layer protocol which uses RTP as a transport for negotiating secure session capabilities. The next discusses the problem that it often doesn't make it through some of the network equipment that's out there. The last bullet introduces the comments for the working group last call. Next slide, please. This is really the heart of what we're trying to get across to the people who will find our traffic on their network. That we have registered two media subtypes, audio skip and video skip with IANA. The format of those to transport traffic over RTP is shown at the bottom with the mapping of skip/audio, skip/8000, and video, skip/90,000. These are the transports of which we will do our work. The next slides will go over the comments. And Dan, you can take it from there.
Okay. First question was referring to some of the language, if you will, of end-to-end security and what exactly that means in the context of SCIP versus other contexts. Bernard, I guess you had this question regarding, in reference to S-frame. We don't feel that S-frame is under consideration for SCIP at this point, only because it's kind of outside the scope of SCIP, if you will. It's SCIP will be a point to multi-point when using a trusted multi-point control unit or MCU for what we're going to be for multi-party video conferencing. So that's kind of where we are with that, and that kind of leads to the second question there of saying application layer security. Well, I believe we're clear in that, and section 2 where we say it's an end-to-end security at the application layer. So unless there's any strong feelings otherwise, I think we're going to stick with that. Bernard, I don't know if you have any questions since you brought
Well,
this up
it was
originally.
just it was just that it's at least the way the term has been used. It refers to going from one endpoint to another endpoint, and since the MCU is trusted in this model, that's not really the case for skip. I mean, you can use the term. It's just helpful for people to understand that the model is not that of an untrusted mixer, right? That mixer's trusted. So the mixer
Correct.
is the endpoint when you use the term end to end. That's the only confusion.
Right, and we didn't really have under when we came up with the text, we weren't really thinking necessarily of the multi-point video mixing situation for that. I mean, normally what Skip's been primarily used for at this point is end-to-end user to endpoint to endpoint at this. So there really hasn't been a central mixing unit, if you will, at this point. So it's kind of where we tend to go with end-to-end security at this point. So
we consider that the Security Association will be a point-to-point type of communication, and we're into a conferencing mode. Depending upon what was negotiated in the session, it'll depend on how it'll be handled. But from the networking perspective, which is really where this RFC is trying to focus, they will not have any knowledge of what's going on other than the RTP payload types we addressed in the previous frame. So all this should be occurring transparently over the network.
okay, any more questions on that, or we can move to the next slide? Okay. Yeah, so the term end-to-end bit integrity, I guess we're sort of looking maybe some suggestions, like I said, we can maybe remove that term from the text as it is. I guess maybe solicit some suggestions about, for example, changing it to no transcoding and no lossy compression techniques shall not be performed on the skip payload. So I guess if there's any recommendations for better text, just to say, don't modify, don't do anything to our data, just let it pass through. No transcoding, none of that stuff. I don't know if there's recommendations for any better terms to use for that we could use. I'll open it up there. Okay, like I said,
It seems okay to me.
Okay, just saying no lossy, no transcoding, and no lossy compression or anything to that extent. So, okay. Next question was about audio and video multiplexing at the application layer. Again, we hadn't really considered that at this point, and it's kind of also, I think, beyond the scope of this skip the skip request, if you will, because that can be implemented independent of how we declare skip at this point. So I think our position is it's kind of, like I said, it's kind of outside the scope of this. And similarly for the reference for bundle, the RFC 9143, it's the same idea that it's kind of outside the scope of skip at this point. So we hadn't really considered it. And if you want to implement it, I think you can do it without any changes to how we've defined skip at this point. So.
Okay. Yeah, so it's not, these things aren't forbidden. They could be, in future it's possible. They're just negotiated like they would be in any other. So they could be negotiated in the future. It's not like inherently incompatible.
Correct. I mean, like I said, I didn't see any. I read through those real quickly, and I didn't see anything that could possibly interfere with skip at this point, how we've declared it. So I think that they are beyond, outside the scope of this, and shouldn't interfere with what we've defined.
Yeah, actually, that does remind me, I guess, Jonathan, would there have to be like an indication of whether, typically when bundle can be supported, you have to indicate the parameters of it, like is it transport or identical?
You know what? Not for payload types, I don't think.
Not for payload types?
type-
Okay.
Yeah, not for payload types. So that's fine. Yeah.
Okay. Next slide. And additionally, Rtp and Rtcp multiplexing. Again, that should be something that can be independent of the skip protocol and should be outside the scope of this RFC. Again, there's, from what I was looking at, reading real quickly on the RFC, there's nothing in there. I mean, these devices can support, doing RTCP on different ports, using the A line for RTCP for specifying different ports, rather than the normal +1, that type of stuff. But there's that RFC also references, and I think that's outside of, it shouldn't have any effect on how skip is defined at this point. So
Yeah, so the overall point was just to indicate that skip doesn't prohibit any of these things. They can be negotiated separately as they were, that was the only thing I was wondering. There's no inherent incompatibilities there.
correct. Yep. And additionally, again, basically the same thing also applies to the additional extended RTCP feedback messages in RFC 8888. Again, that should be outside the scope of skip at this point. So, for using video and things like that, what you probably normally would use in an H.264 session or compatible codec like that should be transparent and use those same methods within skip. So
Yeah, I guess, is it assumed that you always use H.264 within skip as a video codec? Is that the only one you could use, or is it possible in the future that there could be other ones?
there could be other ones in the future. That's the only one we've really considered at this point. It's something that we can define. Hopefully, should be outside the.
Right.
We can define internally, or just
You could just say that for
Yeah.
feedback messages, the underlying video codec applies, whatever that is.
Well,
Yeah,
it's a negotiated, it's a negotiated video session within the items identified in the RFC. So it is within the skip standards. There's profiles that some have been developed, some will be developed later, but the transport path is what we're really looking for in the RFC.
Okay, well, I think that pretty much wraps up the questions and responses at this point. So I guess next slide. I don't know if Mike, you want to wrap this up here, or?
Yeah, I think the problem statement there at the beginning is really why we're here, is because if people don't recognize the skip audio and video skip RTP declarations, then it can often be stripped out. In some settings, it's even unintentionally stripped out because the particular network product doesn't have a setting, a pull-down menu, if you want to call it that says skip in it. So in coming forward and bringing this to light, that what this protocol does, and the community that's out there that supports it, and the established products that are already out there that are using this, we need some way to get this globally accessible reference material out to them. So on this particular draft RFC, the last call ended on the 8th, we've tried to address the comments that we've received. So as we move forward with this, each time we move another step closer. So we're here to ask, once we've made the minor adjustments to the RFC, the draft RFC we've presented, what is the step after that?
Well, the next step would probably be to kick off a number of directorate reviews, including like the SDP directorate. So you'll get reviews from these various reviewers, like what you've seen from the other presentations so far. And then after that would be IETF last call or publication request.
Okay, well, that's helpful to know that too. Our first step is, of course, to get those changes in place and get them up there. And once that is done, I assume it's the co-chairs take on the role of distributing this to the other principal people that need to know.
I guess Jonathan and I will talk, but we'll probably initiate the directorate reviews. And the publication request form is changing, but so I'll probably do that first, and hopefully it'll settle down, and then we'll start looking at the pub rec after the directorate reviews are done.
Yeah. Yeah. I guess we probably want the revised ID before the directorate reviews.
Oh yeah, definitely.
Get these revisions in, and then to the directorate reviews.
Yeah, we'll get that out to you next week. So.
Sounds great.
All right. Thank you.
Is there any other questions anyone has?
Stefan?
Okay. Stefan?
This is not a question. This is a comment. I have observed something that that looks to me like an orchestrated campaign in showing support for the various stages. That's really not necessary to that extent. Yeah, that's just blowing up Me Too mailing list traffic. You don't have to do that. It's frankly, to me, it's annoying and it doesn't add any value. Yeah, so probably don't do it again. Thank you.
Stefan, I agree with you. It's been a little annoying to us too, but at the beginning of this, we were asked that we involve our working group community into this. So we did.
And you're right, but
I think we're beyond that now.
I think you overdid it. So let's not do it again. Thank you.
Yeah. I think it was helpful to make the decision for adoption, but at this point, the process doesn't require that kind of level of community, external community support, so long as it's clear that there is a community for this, which is clear. So.
I agree.
All right, thank you.
Okay, so this is a presentation about RFC 7983 BIS. Just a little bit of overview. That's an update to 7983 Section 7, documenting quick multiplexing, and basically adding that to the protocols that can be multiplexed, and it also updates the DTLS content type field to reference the new RFC, but no other changes needed. So just to remind everybody about how the multiplexing works, it basically works like this. I would emphasize that this is how it works without the quick spin bit. We'll talk about that in a moment. Sorry, without greasing of the quick bit. Sorry, spin bit is irrelevant. Basically, so if you have a quick long header, it's from 192 to 255, so above the range of Rtp, Rtcp. And then if you're talking about the short header, it basically can overlap with a turn channel, but otherwise it's between DTLS and the Rtp, Rtcp range. So that's the scheme that's being proposed. Now, in terms of the recent changes from 02 to 03, we looked into the compatibility with Quick V2. It turns out Quick V2 doesn't introduce any changes that affect the multiplexing, so it's fine with that. We updated our reference for DTLS V3. Then for 03 to 04, we were made aware of the quick bit greasing draft, which does have a major effect upon this because it essentially allows the second most significant bit of this first octet to change, right? That's what the greasing is. So if you are negotiating quick bit greasing as a transport parameter in quick, that is incompatible with this multiplexing. And it's incompatible in a fairly major way because if you look here, if you remove that second bit, set it to 0, then the quick long header will overlap with Rtp, Rtcp. And similarly, if you set that second most significant bit to 0 in the short header, then you will overlap with stun and ZRTP and DTLS. So it's basically makes multiplexing infeasible. It'll break everything. So we added a paragraph to section 1, basically indicating it's compatible with quick v2, but not with quick bit greasing. And so basically the idea is if you want this, you have to not negotiate bit greasing. So you don't indicate support in a transport parameter, you don't negotiate it, so you won't break multiplexing. And we also added a note in section 3 just saying that you can't negotiate bit greasing if you want this to work. So here's the little bit of text from section 1 of the IETF quick bit greasing document describing what greasing is and why. There is a reference to DMUX that is a reference to 7983, not to this document, which is a little odd because 7983 doesn't talk about quick. But presumably that was done because this document had not advanced sufficiently enough to be referenced. So I'd like to open it up to working group discussion. Are we done? Are we ready for working group last call? If people have concerns, what do you think?
I think I don't know of any open issues, and I don't think anyone else has any, so I'd say it's ready for last call. And if we want to try to encourage the quick grease draft, if it's in an appropriate state to reference this, make it a cluster, it'd probably be a good idea, but it's not necessary if they don't want to. That's not our decision. So yeah, I'd say working group last call, personally. And I guess since Bernard is the author, I would need to be the one to do the last call.
Does anyone else in the working group have any thoughts on the bit greasing issue?
I think the thing is, it doesn't work with demultiplexing, so don't do it is probably the right answer. But we might need input from quick stack people to say, hey, do you have a knob to turn this off? But
yeah, that was my question. It's not, there is no such knob at the moment, but
yeah, I suspect we should probably forward this to the quick working group to say, hey, we're doing this. Reviews would be welcome for working group last call. Mo?
Yeah, I think the multiplexing draft is fine. The way that you mentioned all the issues makes sense. Personally, I think the bit greasing will die, even if it's published. I don't think it'll ever be used. And we have many instances of this where things ossify. The first version defines something and it just lingers forever. And I think it's too late already think that you're going to reclaim that bit now by greasing it and make it, available. You don't even know what you're making it available for. So in all video payloads, we have a similar thing. We have the forbidden bit in MPEG. It's a relic, and yet, it still lives in almost all of the video payloads. I think we'll see the same thing at the transport level with the quick second bit.
Okay, I think that's it for this item. Thank you.
Hello, can you hear me okay?
Yeah.
So I wanted to talk about congestion control, about Rtp over quick. I've been reading the paper from Matisse and Gelbart and Jörg Ott. And next slide, please. And for reminders, this paper investigates how to do proper congestion control for real-time media over quick, for an Rtp mapping over quick, and do some experiment to test a combination of congestion control algorithm. For example, especially Scream over quick with a new Reno, and to compare with a Scream over just UDP or a Scream over quick without new Reno, and to see if we can avoid duplicate signaling between RTCP and quick statistics. So next slide, please. So I was looking at their result, and the result about Scream on top of new Reno was caught my attention, because when you decrease the link, we can observe that the transmitted bitrate dropped to 0, and even if you increase the link capacity back, it never recovers. So I decided to investigate a bit further about what was happening. So I tried to reproduce the experiment from their open source code with the same network emulation with TC commands and Docker containers. And next slide, please. I reproduced this behavior, but it was not only happening for Scream over new Reno. It was like randomly happening for other test cases as well. Even just Scream over UDP. Every time Scream was involved, there was this behavior happening randomly. So I considered a test case with a constant rate, a constant link limit, and we can see on the figures on the top right that the target keeps decreasing over the time, which was kind of weird. So I was thinking there might be a bug in the implementation. So next slide. So I displayed all the Scream statistic I could, and I observed that the Rtpq delay was really high once we decreased the link capacity. So the Rtpq is where Scream stores the Rtp packet, because according to the RFC, Scream does not allow to transmit directly the Rtp packet over the network. It is enqueued in the queue before. And this queue is being cleared when it reaches a delay max value, which is computed from the RTT estimated by Scream. And that is what was happening. This queue was being cleared over again. And that is why we have like a 0 megabit per second bit rate. because all the RTP packets were being discarded. Next slide. So in the implementation, when you are using Screen, you need to call a specific method to know if you can send a packet on the network or not, which is okay to transmit. It will return you like -1 if the Rtpq is empty, so you can't set anything, or the congestion window is full, so you don't it doesn't allow you to send any packet. Otherwise, it returns you a time. If it is less than 1 millisecond, you can send packet. Otherwise, if it is above 1 millisecond, this is the pacing mechanism, so you have to wait this amount of time before sending the packet. And when you decrease the link limit, this time returned by this method was always over 1 millisecond. So in the implementation of the experiment, when it was above 1 millisecond, you never dequeue the packet, which means the Rtpq was always full and was eventually cleared. So by taking into consideration this last return value, I had like new results. So next slide, please. And we can see that now we have like no more abnormal behavior for Scream. That even for the constant link capacity, it is always around the link capacity, and it is no more decreasing over time. I'm also looking at the quick statistic from the qlog file, and we can see there that Neurino, when we use Neurino, it is always limited by the application. The congestion window estimated by Neurino is never reached by the bytes in flight, and there is no loss event. So we can say that whether you use Neurino or not on Quick, it will be the same behavior, and that's what. And we can see this on next slide. Next slide. We can see this here. So the figures look like really similar whether you use Neurino or not. Next slide, please. So just in conclusion, I've been reproducing this quick congestion control experiment, and I think I found a bug in the implementation. And after fixing this, I could see that the behavior of Screen on top of Neurino is like really similar to running Screen alone, because Neurino is always application limited. And as a next step, it could be interesting to find a network scenarios where we can see Neurino react, like what it could take to make a lost event or make Neurino reach the congestion window, and also testing other quick implementation and congestion control algorithm. I'm also working on a new experiment to route the WebRTC traffic from a web app on Chrome through a quick tunnel to do network emulation and this. So it is still in development, and I hope to have some good results about this. So that's it for me. So if you have any question. Yes, Spencer.
Yeah, thank you for doing this work, David. Really appreciate it, and it was on a pretty important topic for discussions that I've been involved with certainly. Is there a place where you describe the environment for the experiment a little more precisely, like what bit rates and things like that that you're using?
No, I did not publish like the exact environment I was using. I tried to reproduce the same as was described in the paper, in the original paper.
Okay, good. And like I said, I just wanted to thank you for doing the work a lot, and I look forward to seeing your continued results.
Thank you.
Enjoy your IETF.
Thank you. Yes, Jörg?
Yeah, I mean, there's nobody in the queue to comment. I mean, I guess sort of the takeaway from this is that Scream, because it's keeping low delay, basically limits you more than Neurino, and Neurino is essentially not doing anything. Is that sort of the Neurino is always application limited, so it'll always say yes if I descend.
Yeah, Neurino like does not react in the experiment.
Okay, yeah, and I guess sort of the interesting thing is, as we've always had the intuition that Rtp over TCP is terrible, but I guess the lesson from this is that's because of head of line blocking, not congestion control. So that's an interesting takeaway.
Well, we'll also keep in mind that this was a single stream experiment, so simulcast would behave a little differently.
Yeah.
Depending on what level you're doing, what Scream is congestion controlling, but yes.
So yeah, sure, I don't know.
Can you unmute?
Oh, Mathis.
I see Jorg in the queue, I guess.
You hear me?
I don't know. Who's in the? I'm sorry. I'm not sure who's for. Who?
Can you hear me?
I can hear you.
All right. Then I go first. I think you just forgot to lower the hand. I have a question to, I think it was slide 36. Because I think this fix you presented might include one fix we already presented in February too, which was that we sent a lot of RTCP feedback, which caused a congested feedback link, and in turn resulted in a bad bandwidth estimation. And here on the slide it says the received bandwidth in the blue line. So I assume this is RTCP on the received by the sender. And on this slide, it's like something around 800 kilobit, I think. If you go to the results slide after this, like with the fix, I think it is like 200-ish or so. So I think this might include the fix we also presented in February. And I was wondering if you have results without this fix included, because that might be interesting when you look at different pacing mechanisms, right? Because you have running a screen pacer at the application layer. And if you disable this, which is kind of what you did, I think, if I understand it correctly, then you only have the Neurino pacer below, and might be interesting to see the results if there is a difference between running both or only one of them. And I think that might be interesting to one part in our draft, which we're going to present later.
Sergio?
Yeah. So first, thank you very much, David, for this great job. And I think that this also matches my expectation about how I expect any delay-based congestion control versus a loss-based one like Neurino. So I think that it would, or my good feeling is that it doesn't matter how much, even if simulcast or how much bitrate we send in with a Scream, that the key is going to see what happens when new Reno kick in, because, for example, you are sending a file with a quick stream, and there is a stream stream going running simultaneously. And I think that this is the main thing to see what is the effect of new Reno over a stream where new Reno is kicking in, because there is another, it is sharing the link with other loss-based congestion control.
Do you mean sharing the link or sharing this congestion state? Like something else?
I think that it will be kind of the same. I mean, I think that both the scenarios. I think we need to test both the scenarios, but I expect the same behavior to happen. But yes, I think that we need to test first what is what happens when we have new Reno or one stream and one quick stream with that it is competing about the bandwidth of on the same new Reno transport, and having one transport with new Reno and the one transport with the stream alone.
Not this?
Yeah, so I am not sure if I understand this correctly, but if I understand correctly, your suggestion is to measure that or when exactly new Reno kicks in and stops the screen control traffic from sending, and test this once with only sending media over stream over new Reno, and once with sending media over stream over new Reno, and in parallel send another stream which is only controlled by new Reno, right? I think we have some tests on that, and I think we have presented that in February too. I'm just not sure now. Because in that case, what we saw is that as soon as we start sending data which is only controlled by the Reno controller, for example, on a quick stream next to the datagrams, then the stream basically takes up all the bandwidth, because yeah, it just uses all of the congestion window in Reno, and Scream sees growing queues and then just degrades the target bit rate further.
Yeah, but if the implementation has the bug that David has discovered, I mean, it is likely that the Scream going to 0 is also maybe because the bug. So I think that we should revisit these results anyway.
Okay, so anybody want to say anything else? Otherwise, we should probably move on to this New York's presentation. Sorry.
Yeah, hi. So we have not done any new experiments today. We just like to present an update on our draft, which we, I think, presented last July for the time. And we have basically done a couple of restructures in the last weeks and months and 2 versions. And I would like to talk about the main sections we have in the draft now. So next slide, please. So the first one is about encapsulation, and I think the biggest slide we have added is that we included a version for Rtp over quick streams now. Previous versions was only datagrams, and that was also what we had in the tests we presented the last meetings. The version for Rtp over quick streams now specifies that one stream is used for one application data unit. So a sender can put one application data unit in an RTP packet and send that over a stream. And as soon as it's done, close the stream. Patrick, you want to go ahead just now, or?
Yeah, just was wondering what is an application data unit and how do you map RTP packets to quick streams?
Well, so what we have from the layer above is that we have some, I guess, format types which are different for different types of data. And when we want to put that into an RTP packet, into the quick stream, we just say that that we put one of the units which comes from the layer above into the RTP packet, and only one RTP packet on one stream, and then afterwards the stream has to be canceled. Does that answer the question?
Basically treat this as an RTP packet with an infinite MTU. So basically put whatever the largest thing that's useful as one packet. So like ideas like for a video frame, you'd put an entire video frame.
Yes, exactly. Okay. Yeah, then exactly when the packet is no longer needed at the receiver, or the sender says it's too late to transmit this again for retransmissions, for example, it can cancel the stream at any time. And that way we can use the same encapsulation format for datagrams and streams for both our mappings. Because if you remember, we had the encapsulation for datagrams, which included a flow identifier and then the following RTP packet until the end of the datagram. And now we use the same thing for quick streams, prepend the RTP packet with the flow identifier, and then fill the rest of the stream with the packet. We will get to RTCP on a later slide. And on that later slide, we will talk about how to reduce RTCP overhead as much as possible by reusing quick statistics which are present at the connection. And one thing to keep in mind for RTCP, for stream-based RTP transmission here, is that we try to use as much as possible the quick statistics, because if we use the RTCP, which is of course mapped to quick streams in the same way RTP packets are, then there might be wrong statistics coming from the RTCP because of underlying quick retransmissions. And yeah, so this way we should hopefully be able to use quick connections also when no datagram support is available in the implementation. Next slide, please. So now for RTCP, we allow all RTCP by default, like usual, and can send RTCP packets in either datagrams or streams as described in this previous slide. And then we try to provide some guidelines for how the most common RTCP packet types can be mapped to quick, which means that the data which is usually transmitted from a receiver to give statistics to the sender can be inferred from the quick connection statistics and received by the sender without using RTCP. And for that, we have a section which now describes in more detail than it did before for specific feedback types, how this feedback can be extracted from the quick connection instead of using RTCP. This mostly works for receiver reports, NACS, ECN, congestion control feedback, and some parts of extended reports. And then, of course, in the future, if there are more RTCP packet type definitions, that can be extended by future mappings. And for a few other packets, one second, like sender reports, for example, and a lot of application layer control packets, this cannot easily be mapped to quick. And in that case, we, of course, still need to use RTCP.
What is the issue with this? I mean, they cannot be represented from quick information is what you mean. They need to be.
Yeah, exactly. So when the sender sends SR to the receiver, or the media receiver, he basically does that to provide some timing information, and we cannot easily map this timing information to quick connection statistics. And of course, if the sender report also includes receiver report afterwards, then that is the same as the receiver report above. Then one open question we have for this section is whether we actually want to just map one-on-one all the RTCP contents to the quick connection, or whether we actually want to use all the quick connection statistics, because there are probably a lot more data points from the connection in quick than just by mapping the RTCP itself. Then next slide. Next slide, please. I'm still seeing the old one. Oh, thanks. For congestion control, we also restructured a bit and added more information about how congestion control can be done for or in different options. We give the sender the choice how to do this. And the first option we included is to do congestion control only at the quick layer, and that quick ideally use low latency delay-based congestion controller, and possibly one of the RMCAT proposed ones, and then expose a bandwidth estimation from this quick connection to the application to allow the application to configure the codec. And in this case, the application doesn't have to do any bandwidth estimation itself because it can query this from the quick connection. And then the second option is to use a congestion control at application layer. This could be useful, for example, if there's no low latency congestion control available in the quick implementation, or if the quick implementation does not expose a bandwidth estimation for the application to use. And in this case, we could use Scream or NADA or GCC on top of the application, on top of the quick implementation. And as we have seen in the presentation before, in our results in February, we saw that it is possible to run Scream on top of Neureno, and this seems to work with application limited traffic as long as the traffic is application limited. And of course, there may be other congestion control algorithms running in the quick implementation for which this might not be true. So in that case, we still added a sentence explaining that it may be useful to disable quick congestion control completely when it is done at the application layer. For the RTCP feedback for congestion control, we did not include anything in this section because this should all be covered by the RTCP section before. Next slide, please. So then we have some signaling. We included in our first draft 0.0 last year a section on SDP signaling, which we have not updated since. And now there's also Spencer's draft, which he's going to present later. So we didn't focus on updating our section on this anymore, and instead talk to Spencer about what actually need to be signaled. We have a few issues or list of things which are included in our 0.0 version and which we need signaling for. So the things we included in our 0.0 draft are on this slide, and this is basically connection setup and removing, adding flows from a connection, and then of course the media flow ID mapping for the flow ID in the encapsulation. And then one thing we realized recently is how zero RTT, or what zero RTT might have, or what implications zero RTT connection setup might have on RTP over quick and signaling. And this might be, for example, useful for avoiding clipping in connection setup. Then the second slide on SDP signaling, please. There's one more. Yeah, thanks. This is mostly issues we have not included in our 0.0 version, and instead will probably go to Spencer's draft. And I think he included one or some of these already in the presentation today later, or in his issues list. Of course, since we now have streams and datagrams, it must be chosen somehow which of those to use. One option could be that the receiver indicates some capabilities to the sender, and the sender then chooses, but still we need some baseline to be defined. Then for the RTCP statistics replacements, we need some capability signaling, which says that a receiver or sender is actually capable of using quick statistics and wants to turn off RTCP for certain packet types. And congestion control itself can then be done by the sender unilaterally. But of course, he still needs to signal the correct feedback or negotiate the correct feedback mechanisms. Yeah. Sergio?
Yes, one thing that I'm not sure if it should be considered in this draft or in the SDP. I mean, how this, especially I'm thinking about the flow identifier, how that interacts with ICE. I mean, if you are thinking about using the multiple flows or Rtp transport within the same quick transport, how does it work with using ICE too? I mean, not saying that you have to answer now. Is something that we should consider how to solve it here or not?
Yeah, I think you're talking about both in the same connection, right? I think that was one idea actually why we kept the flow identifier, not only to demultiplex different RTP streams, but also to demultiplex between different applications running on the same application. And one question we have as a discussion point in our draft is how this flow identifier can be managed efficiently between different applications. Because I think HTTP3 datagrams also use the flow identifier, and if everyone defines their own way to demultiplex different flows, that might be a problem. But yeah, that's also a discussion point in our draft.
Mm-hmm.
Yeah, Srinivas?
I have one question on slide number 43. So you mentioned that do not use timing information from RTCP reception. So does that mean like sometimes RTCP also supports feedback messages such as custom feedback messages such as viewport information and other stuff. So sometimes we may also have information like we probably need in viewport from certain time onwards or something. Such kind of timing information may be incorporated into the RTCP custom feedback messages. So is it just like you just ignore the RTCP packet receiving time, or even the time information provided in the RTCP packets also was?
We try to map the contents of the RTCP packets, for example, for congestion control feedback, which says that one specific RTP packet arrived at the receiver at a certain timestamp, and we try to map this to connection information from the quick layer. So if the quick has information about that a certain packet arrived, then we can get that from the quick connection instead of sending another RTCP packet containing this information. It's not directly about RTCP packet timestamps.
Okay, so anything in the timing information is part of the RTCP packet still can be considered by the application. That will not be discarded.
Yeah, I think so.
Okay.
Then Spencer, probably on signaling.
For the presentation, as always. Looking at slide number 47, I just realized I didn't know quite what these words meant. I had looked at them previously, but if you're looking at slide 47, which is I think SDP signaling 2, maybe the next slide. When you were talking about exporting statistics from Quick, are you talking about exporting them up to making them visible to the application, or something else?
Yeah, so we need Yeah, the quick connection needs to expose them to the application somehow, and if that is possible, the application might want to signal to its peer that it is possible to use the quick connections and no need to use RTCP.
Okay, cool. Thank you so much.
Yeah, you're welcome. Bernard? Yeah.
Yeah, so I guess let's talk about the next steps.
Yeah, that's the last slide we have. So we would do a few more updates which we have, or which we mentioned above, and then security considerations and IANA registrations are still missing. And then the next step, which would be maybe the working group adoption, is something, yeah, we would like to ask and to give into discussion if that is something the working group might want to adopt.
Okay, so you're requesting we run a call for adoption after you submit the update.
Yeah.
Okay, I think, Jonathan, we can take that as an action item, right?
Yes.
So please
I
note
also
that
see-
in the notes.
Yeah. I also see several other people in the queue, though. Are you speaking to that? Georg, or I guess that's a Spencer also.
Can you hear me?
Yes.
Yeah.
Okay, good. I believe the question for working group adoption, actually, since we are talking about some minimal security consideration section and IANA registrations, mostly plus some minor updates, I wonder whether we can actually get a sense right away. And I'm not sure whether we actually do need to wait for an update of the draft, since the fundamental aspects don't change. Of course, it's certainly fine if we take some extra weeks until we have updated it and get people more time to read. But I don't think these two things do necessarily have to happen in sequence.
Spencer?
Yeah, thank you. I just wanted to say I would encourage you all to do the call for working group adoption earlier rather than later, just because people like me and other people are kind of looking at this individual draft as if it is going to be kind of the baseline. But since we haven't adopted this draft or any other draft, that's not actually a good plan for them. So from my point of view, this draft is certainly in shape for us to use it as the basis for the working group to work on it. So I would encourage you guys to ask the question earlier rather than later. Thank you.
And I also infer that your personal opinion is that it should be adopted?
Oh, yes, absolutely.
All right. I guess Bernard and I will talk about that, but yeah, we will. Sounds like we should do a call for that. Soon.
Okay. All right. So I guess we're going to turn it over to Will Law because Jan Ivar has COVID. Ooh.
Yeah, good morning. Can you hear me and see me before I launch into the ether?
Yes.
Okay, thank you. So good morning, my name is Will. My co-chair, Jan Ivar, was going to do this talk, but he got COVID yesterday. I got COVID 3 weeks ago, so I am the lesser of the COVID inflicted in our group. So I'm going to do the talk. So thank you very much. We're coming to you as the W3c Web Transport Group. So this is a group of people who are charged with creating the APIs for a JavaScript client to be able to use web transport. And most of our use cases are satisfied, but the use case we care most about is the one that's still the challenge. And that's exactly what we have here today. It's me talking to you, low latency audio or video. And the problem is the client, in sending data up to the server, doesn't have enough information to know when it can apply a multiplicative increase in the send rate, so to recover from congestion and ramp up again. So we really want to know if RTP over quick can satisfy this use case. And if the answer to that is yes, then what measurements need to be made available? And will selectable congestion control be required? So Mattis's prior presentation is actually very, very relevant to these questions. We have additional slides, and then we're going to come back to these questions later. So if we can go to next slide, please. So just as a reminder, we're dealing with web transport from the point of view of a browser-based API. So web transport built on top of HTTP3, built on top of Quick. It is not coupled tightly to the Quick stack. So the JavaScript has no access to Quick. There's copying happening. There's queuing and buffering happening from the streams, the WhatWG streams, say that might come from a web codecs implementation, into the send queue for web transport, into either streams or datagrams. And the API has no visibility into the transport layer. We have an interface for streams. We have an interface for datagrams. Next slide, please. This is just documenting our open issues. So our open issues are about congestion control, bandwidth estimation, and also the notion of pluggable congestion control. And I think Bernard here also linked some of this work group's relevant discussion points on the same subject.
So yeah, we just put down here two things which we thought might be relevant to your request. One was the information that's in RFC 8888 section 3, describing, for example, feedback info that was relevant potentially to these low latency congestion control algorithms. And you see here packet arrival times, ECN markings, flows, and then draft Engelbart, which in its 02 version, section 5.1, also talks about metrics that they were using to compute the bandwidth estimation, which is potentially relevant. Some of the same things, departures, arrivals, RTT estimations from the quick stack, NECN. So these are some of the things that were going to be suggested as potentially relevant.
Okay. And here we see what we have today in terms of stats accessible to the JavaScript client. So it's at an aggregate level, bytes sent, packets sent in total, packets lost, number of streams, bytes sent received. You'll notice we did actually copy out the RTT variants. Aside from the latest RTT, we do have smoothed RTT variation and min RTT with the same algorithms used to calculate those. And on the datagram side, we just have expired outgoing, dropped incoming, lost outgoing. So what we're missing is any explicit congestion notification, ACK info, the latest RTT, and information about packet arrival and departure, because we're obfuscated away from the actual protocol. Next slide, please. So these are our core questions, and maybe we should just do them one at a time. Do RTT measurements need to be adjusted? I guess the bigger question here is it actually feasible that a JavaScript application will be able to either apply its own congestion control or work in cooperation with a browser user agent that is actually managing the quick connection? And it seemed from what Matt has just presented that the answer might be yes, that you could have a default congestion control working on quick. Given enough information, the application, in this case JavaScript, could implement Scream or another protocol and be able to meet these requirements. Is that in fact feasible if the application is JavaScript in a browser?
Does anybody want to give their opinion to Will?
Or I'll make it a rhetorical question if there's not actually an easy answer. Matthias.
So I think it's hard to answer specifically for JavaScript in a browser. Our tests used not JavaScript. We did it like we had access to the quick stack and everything in a separate application. So maybe some tests on this would be good. to experiment if the JavaScript application in a browser with their specific environment can implement this, and whether this works as well as it did for our experiments and the ones David presented earlier.
That would be very interesting. And in fact, that is our request. We do not have experimental or research access within our group, and there are individuals and organizations within this group would do. So it's a clear request to make and to use the web transport. It's available in Chrome today. And there's also a server implementation to see, and in the short term, basically provide feedback as to what would be the necessary minimum information to be relayed to the via the browser to the JavaScript application. So do RTT measurements need to be adjusted? I assume we could send the latest RTT and make that available. In addition, that would seem to be a good idea. Packet arrival and departure information, is that also something feasible to relay to up through the browser to a client? Bernard, are you going to call Q?
Sure, I guess Mathis. Mathis?
Okay, all right.
You want to comment?
I'm not sure if RTT measurement is that helpful anymore. We included that in the first version of our draft, but I it's now not that sure anymore if it is really that necessary. We included it because we thought if the congestion control algorithm running in the application only uses the other information to calculate their own RTT, then we can give it directly from Quick. But I think what is more important to these algorithms now is to have information about packet departure and arrival, or maybe even something like one-way delays between departure and arrival. That could also work, I think. But maybe some people with more insight to other algorithms, congestion control algorithms, can say more about that.
Okay, thank you. Roman?
From kind of independently working on the congestion control algorithms, not necessarily Quick related, you can do it from JavaScript. You just need to get the aggregate information about packet arrival, either as a set of inter-packet arrival delays as an array, or if that's too complicated, you can even get away with getting the sum of squares and sum of and basically and the average, because that will let you calculate essentially like a standard deviation, etc., for any given interval. But that's that can be used for essentially estimate bandwidth estimation, etc. So you can. But the actual array of interpacket arrival is probably ideal for the bandwidth estimation.
Okay, sorry, I'm just taking notes. Thank you. Mo?
Yeah, I think if the goal is to allow application level or JavaScript level media rate control, I think that's still a little bit different than congestion control. I think browsers will always have some sort of congestion control on the connection, whether it's Quick or whether it's anything else. There'll be some level of congestion control running on that connection, and so you'll need to expose what that congestion control is actually sensitive to, not just what the JavaScript wants to use as the parameters that govern its media rate control algorithm, but also it's going to be fighting with some lower level congestion control, and it needs to know what the stats of that congestion control are, so that if, for example, you want to try to find the bandwidth estimate, the underlying CC may have already found some bandwidth estimate, and if you don't want to conflict with it, you obviously can't exceed its bandwidth estimate, or the underlying CC is going to withhold your packets. So you need to be able to understand what does the underlying CC in the browser, what parameters does it already enforce, and you need to surface those, because the JavaScript algorithm is going to have to work around those.
So that's exactly our last question on this slide, which is, okay, we realize we have competing, or not compete, we have congestion control that's already present, and we've thought about having a constructor in the web transport, an argument in the web transport constructor that would hint to the user agent that's managing the connection that we wanted to shift to a different mode of congestion control, perhaps a native one, perhaps one that's more conducive to us than modifying or understanding the send rate. So that the last question there is, should there be a default one specialized for low latency perhaps, or even a circuit breaker one, which is one that gets out of the way completely unless things are going haywire, in which case it trips and it tries to restore the connection, or something else completely.
Applications would love that circuit breaker approach, but I'm very skeptical that popular browsers would enable that much freedom to send without limit. It seems like a perfect AMP attack vector for anyone.
That has been the feedback. So then, assuming are there candidates for a congestion control that might be more amenable to a JavaScript application running on top of it? Like, is GCC or is there an obvious candidate there already that we could? Our trouble is we need to put something into the API. At this point, it's what's holding up our candidate release, that we don't want to constrain it too much. We can make a generic entry called low latency, and then later on through experiment, we could determine that it's a certain algorithm. But if no algorithm is likely to ever satisfy that requirement, then we don't want to bake in an API argument at this point that we would then have to remove later. That would be bad.
I think your first options make sense.
Stefan, okay. Do you have a comment, Stefan?
Right.
Yes, thank you. So a lot of things have been discussed already now while I was in the queue, but I think first of all, Mo is onto a lot of things that I was thinking about, where it really matters what the congestion control inside the browser is. And of course, I think to build an application level congestion control that is really working well, a circuit breaker would be the best option. I know that it's possible to get it to work also with something like New Reno underneath. I've tried it myself with web transport and gotten the GCC algorithm to work reasonably well. What I was missing was primarily the packet departure and packet arrival information. So I think getting that on a per send basis in some sense would be very useful when implementing at least GCC. What was I thinking? I guess I'm not sure how valuable it would be to be able to specify a low latency congestion control. I would imagine that most applications that want to use web transport to essentially replace WebRTC would be wanting to experiment with their own congestion control algorithms. I think that's one of the more valuable things I think this transport could expose to the application writers.
But the experimentation would have to happen at the JavaScript layer. There didn't seem to be consensus that JavaScript would be capable of that, even if given the right information, that there would still be a need for some underlying congestion control to be present.
Right.
Are you arguing for the latter, that in fact JavaScript could do it given the right information of packet arrival time?
Yeah, so I think it's possible to get that to work well on the application layer and to decide at what rate to send based on the arrival times and the departure times. That I think is feasible. Of course, you might end up in situations where the application is running a bit too slowly, and therefore you're not able to maximize the throughput of the link. But I don't think that really matters, because if the application is running that slowly, it will have bottlenecks elsewhere anyway.
Okay, thank you. Sergio.
Yes, I think that regarding the implementation of the different congestion control in the browser, I think that the idea is to be able to, instead of, for example, as we have seen before, the experimentation between Screamer and Neurino, to be able to have the quick transport to use a more friendlier congestion control, that it is not loss based but latency based. So I think that this is the idea. So based on the experiment below, maybe it is not needed, but I think that it is still a good idea to be able, for example, to be able to configure a different one like BBR or COPA for quick, and be able to implement a stream on JavaScript.
Okay, thank you. Roman?
Typically, the real-time congestion controller is more aggressive than the like a normal congestion controller, unless there's like some anomalies. So if everything works correctly, the real-time congestion control will limit the bandwidth more than what the default implementation should do. So it will be more restrictive. The second thing, like if it's feasible to implement it in the JavaScript level, it is. We kind of played with that a bit, and it did work. Like the only issue is like you need to expose essentially either aggregate information or expose information. Like you don't expose information about each packet individually. You need to provide essentially in sufficient chunks so that you can batch the processing up, and then JavaScript provides sufficient performance to do the bandwidth estimation.
Is the time base for the batching, or the count of packets over which you're applying your averaging, would that have to be flexible? In other words, should that be part of the API to say, I want my average packet arrival time calculated over so many packets? Or could the browser just say, yeah, we define a metric that will work for everyone, and the browser just delivers that?
One way of doing this is to expose, as I said, expose the metric where you calculate the sum of interpacket arrivals and sum of squares, which gives you like at least some estimation, like second order estimation. But even having access to an array of like X elements, last X elements, it will provide even more detail. But instead of just essentially instead of just looking at the last interpacket arrival, you have an access to some sort of a buffer of X last elements to process and to do the bandwidth estimation.
Yeah,
I think
my
we're going
question
to have
is,
to
should that
move on to the next item soon.
We're getting cut off. Okay, sorry, Bernard.
But we can definitely follow up on the list also, right? People, if you have any other questions, well.
Okay, well, thank you very much for adding us to the agenda.
You're welcome. Thank you. Okay, Spencer, I think we're may have to be pretty utilitarian with respect to time, but go ahead, Spencer.
Yeah, I'm shooting for 5 minutes. Does that sound
excellent,
about right, guys? So basically, I'm just reminding people that I'm keeping track of a individual track specification that is defining the SDP for RTP over quick, and then so that's the minimal specification, and I've also got a separate GitHub repo that I'm doing broader issue tracking, where I'm trying to limit the work I'm doing on the first specification to boiling a small amount of water. so I've got feedback in this presentation, and I'd like for some of the issues that have popped up here, and my goal is to issue a 01 of my draft. And whenever we adopt a draft for RTP over quick, like I said, I'm trying to run aligned with them. So next slide, please. So this one has been a lot of fun on the mailing list, and I have a suggestion. But the suggestion is basically, we know we need to do quick RTP AVPF at a minimum, and the secure AVP profiles are ambiguous, and I've got some details there about whether this is, whether that actually means double encryption or whether it doesn't mean. But this seems to make the most difference when quick RTP over quick traffic hits the middle box. Next slide, please. So we could do, like I said, we could do that one now, and we, that's, I've got a PR that even does that, that I was waiting to apply before people could look at this and think about it a little bit more. I've got some solutions for what to do with middle boxes, or proposed solutions for what to do with middle boxes, but none of them require anything in the SDP, or in the RTP over quick specification. Next slide, please. Streams, datagrams, or both. I am not seeing any convergence about people saying we're only going to use one or we're only going to use the other, and being able to convince people. So my proposal right now is to include both stream and datagram in the SDP. That, like I say, that's where that is. Like I say, I note that I'm using the Engelbart draft as the basis for my work, so adopting it would be awesome soon. Next slide, please. So, am I getting close? So we talked about congestion control. So we have basically a lot of bad ideas that I've even crossed out already. And where I think we are right now is exploring whether signaling anything quick about anything we need to do differently at the quick level for congestion control is a problem in practice. Admittedly limited testing, it hasn't been. If we find out in additional testing, we can come back to that one. I think that is all of mine, yeah. So like I say, okay. I'm looking forward to input in either in GitHub repo for issues or for on the mailing list. Thank you all. And I'm out.
Thank you. All right, so we're going to turn it over to Laurie.
Thank you very much. I'll try to be fairly quick as well. Hope you can hear me okay. So we can maybe just push on. So a quick background. So we introduced this topic first in February. And as a reminder, the W3c is kind of compressing the video scene into different bit streams, once encoded with video encoders and once with encoded with W3c encoder, which is just an encoder for the Atlas metadata. And it very closely resembles how video is used as well. Like in terms of the high-level syntax, it's also based on null units. Next slide, please. Next slide, please. Yes, please. Yeah, thanks. So for the video components, we can already stream those using the existing RTP payload specifications, but we're missing the RTP payload specification for the Atlas data, and that's what we are defining here. So in addition to the RTP payload specification for the Atlas data units, we want to introduce a couple of W3c specific payload format parameters that will allow us to kind of identify the streams and figure out how to use those in the streaming context. And also introduce a grouping mechanism for these different video streams and the Atlas data stream. And then lastly, but not least, we have this Rtp bundling, Rtp stream bundling opportunity that could like allow you to stream a bunch of these different streams in the same port. Next slide, please. So from the previous meeting, we got a little bit of feedback to align more with the VVC instead of HEVC Rtp payload format, and we did that by removing the multi-time aggregation packets and cleaning up the payload format parameters section. We also looked into the SDP, but based on the discussion that took place on VVC, SDP examples and such, we felt that it's fairly okay to be very limited in that regard. And if people want to see more examples in the SDP, for the SDP, that's just fine. Let us know. We also received a little bit of public feedback regarding the missing acronyms, and that we also reflected in the next version. Next slide, please. For the next steps, we appreciate a bit more feedback, and you can do this directly on the GitHub. That's linked here on these slides. And we will be continuing to update the draft based on this received feedback. And we're also looking for additional authors or contributors, and definitely would value input from the Rtp payload format experts, as this is our first time looking into this topic. What we are familiar is more of the W3c side of things and the system sides there. And just as a last, we also introduced this topic in 3GPP to see if there's some interest. And we did receive some feedback, which is not yet reflected here. And that's that. Any questions or comments? If anyone wants to work on this project with us, just feel free to drop me a line, and we can arrange some offline discussions to see what can be done.
Bernard, I'll put myself in the queue. Can anybody hear me?
I guess I can't. Mr. Zhao, are you in the queue?
Yeah. Yes. Can you hear me though? I'm just curious.
Yeah, we can hear you. Yes, go ahead.
Okay, that's great. So just question further. What's the status in 3GPP? I'm assuming it's going to be SA4 working group, right? Which sub working group? And what's the status in there?
I'm sorry, I actually missed all of the discussion or questions. It seems that I can't hear anything when I have my audio on.
Yeah, the question was about status in 3GPP.
In 3GPP is that it's part of the proposal or whatever discussion paper will be put into a permanent document. I'm not familiar with 3GPP, so I don't know what in practice that means.
It's been explained to the RTC sub-working group and video sub-working group. It has been introduced by Nokia in that, and currently it is under discussions. The decisions have not been taken anything on that. It's been just still under the discussions.
Okay, thank you. So it's a video sub-working group. All right, thank you.
Video.
Okay, are there any other questions relating to this item? We're almost out of time. And so I don't even know that we have enough time to talk about wrap up the next steps, but hopefully the notes contain all the action items and next steps for various folks. And we will, as usual, update the action item list and send the minutes to the list and all of that good stuff. Any final comments, Jonathan?
No, I don't think so. Other than that, there has been some discussion of things in the chat that wasn't raised at the mic, so people should review the chat. That's, you know, which I think should be archived somewhere on the IETF site. Other than that, I don't think so. And I think we will figure out our Spencer, do you have something to say?
I was going to suggest that you cut and paste that into the bottom of the minutes. I've been encouraging working groups to do that, and it's been very helpful because sometimes there's a lot of discussion there. Thank you.
Okay.
Yeah, that would be a good idea. Okay. Well then, thank you everybody. We will see you again at IETF 114. Stay safe.
Hey, Bernard. So do we need to copy the Jabber conversation in the notes? Is that what we're talking about?